Hello everyone, I am A. Gayatri Achari, Assistant Professor in CSE Department. Welcome you all to my video creation activity based on operating system. The topic of this video is swapping. Swapping is a process that interchanges the contents of an area of main storage with the contents of an area in secondary memory. A process must be in memory to be executed, but a process can be swapped temporarily out of memory to a backend store, then brought back into memory for continued execution. This is an example where swapping of two processes using a disk as a backend store. Let's take an example. Round-robin CPU scheduling algorithm. When a quantum expires, the memory manager will start to swap out the process that just finished and to swap another process into the memory space that has been freed. In the meantime, the CPU scheduler will allocate a time slice to some other process in memory. When each process finishes its quantum, it will be swapped with another process. The memory manager can swap processes fast enough that some processes will be in memory ready to execute when the CPU scheduler wants to reschedule the CPU. A variant of this swapping policy is used for priority-based scheduling algorithm. In this case, if a higher priority process arrives and wants service, the memory manager can swap out the lower priority process and then load and execute the higher priority process. When the higher priority process finishes, the lower priority process can be swapped back in and continue. This variant of swapping is called roll out, roll in. A process that is swapped out will be swapped back into the same memory space it occupied previously, and the restriction is dictated by the method of address binding. If the binding is done at assembly or load time, then the process cannot be easily moved to a different location. A process can be swapped into a different memory space, as the physical addresses are computed during execution time if the execution time binding is being used. Swapping requires a backend store, and backend store is a fast disk, as in the diagram it is mentioned. It must be large enough to accommodate copies of all memory images for all users, and it must provide direct access to these memory images, and the system maintains a ready queue for all processes. Whenever the CPU scheduler decides to execute a process, it's called the dispatcher. Dispatcher checks to see whether the next process in the queue is in memory. If it is not, and there is no free memory region, the dispatcher swaps out a process concurrently in memory and swaps in the desired process. Thank you.